Okay, welcome back. We are going to go over the law of sines today. Give me 1 second. Let me get this set up so you can see it. Okay, I think that's good. Okay, so law of sines is something you need to know. Up to this point, we've learned how to solve triangles earlier in the semester using SOHCAHTOA. So we were solving right triangles. But what happens when we have non-right triangles? So that's where we're going to start this lesson. We're going to be talking about, from geometry, angle, angle, side angle, and side, side angle. As you know from geometry, that angle, side, side was not a congruence theorem. That means that is not enough information to determine one unique triangle, and we'll discuss that a little bit later. You should easily remember that from geometry. So let's just review triangles in general. Again, we're talking about non-right triangles. Triangles that do not have a 90-degree angle. So angle C is always across from side C, angle A across from side A, angle B across from side B. Doesn't matter where you put them, just as long as the letters correspond. Now, these are the law of sine ratios that you need to know. These proportions are always equal to each other. So A is to the sine of angle A, as B is the sine of angle B, and C is the sine of angle C. And since they're proportions, you can flip them over as well. So the sine of A is to side A, as say the sine of angle B is to side B. And the sine of angle C is to side C. And you will see me use, when I'm trying to find an angle, I will start with my unknown at the top because it's easier to solve. If I'm trying to find a side, I will start with my side on the top because it's easier to solve. So both of these proportions, these or these, are all equal to each other. Okay, so let's take a look at our first example. Hopefully you remember from geometry how to read the given information. Okay, to read this, you can't go side, angle, angle, because you skipped this side. Okay, so this is angle, angle, side. That's the given information, angle, angle, side. You can go from an angle to an angle. Okay, so that's how you read that, angle, angle, side. All right, so we're going to find angle C. So if you know the two angles of a triangle, how do you find the third? And I challenge you to use your calculator and double check that you can get these values, and don't just trust me. If you need to pause the video at any time, feel free to do that. So angle C here is 180 degrees minus 45 minus 30. And if you type that into your calculator, you should come up with 105 degrees. Okay? Angle, angle, side was a congruence theorem. Again, that means one unique triangle with this given information. There's one and only one possibility. Okay, so to find side B. So I'm trying to find side B, so I'm going to start with my unknown on the top. This is what I'm trying to find. Law of sine says side B is proportionate to the sine of angle B. Well, angle B here is 30 degrees. And I can use either one of these proportions. I'm going to stick with the given information that I know is a fact to be true, because if I type this into my calculator wrong and I use this and this is wrong, this is going to be wrong. So stick with the given information. So if we look here, these two pieces we know for a fact are true. Same thing over here. These are true. So the side that we are given is 32, and that's proportionate to the sine of the angle across from it, which is 45 degrees. And then we can easily multiply both sides to solve for side B. So we multiply both sides by the sine of 30 degrees, and you can now calculate side B. And again, I would challenge you to make sure you can type that into your calculator correctly. And side B, we're going to go ahead and round to the 10th, 22.6 units, whatever the length would be. Okay? And now we find side C. Now side C is here. Side B, we already calculated. We're trying to find side C. Now a lot of people are going to jump right to the Pythagorean theorem, a squared plus b squared equals c squared. But C is not the hypotenuse because it is not a right triangle. So make sure you don't make that mistake. Okay, so again, I'm starting with my unknown. C is to the sine of angle C. I'm going to hope that this is correct, that I calculated it correctly, because I have no other choice except to use it. And again, I can use the ratio from B to B. And again, I calculated B to be 22.6. But again, I don't want to use this because in case I make a mistake, I'm always going to use the facts. I know for a fact that 32 and 45 are correct. So again, to solve for C, I'm just going to multiply both sides by the sine of 105, and I will type this into my calculator, and I will get 43.7, again, units, whatever the length might be, they don't give it to us. So 105 and 43.7. So I'm just going to go ahead and put these values here. This angle right here is 145 degrees. Side C we calculated as 43.7, and side B we calculated at 22.6. Now one of the reasons why I'm doing that is because I want to make sure my answers make sense. From geometry, again, you should know the larger the angle, the larger the side across from that angle. So 105 is our largest angle. Side C better be our largest side, and it is. 30 is our smallest angle, so this better be our smallest side. Middle angle, middle side. So if that doesn't happen, something went wrong. So you can double check. Okay? All right. Let's take a look at a story problem here. It says, because of prevailing winds, a tree grows so that it was leaning 6 degrees from the vertical. So the tree is leaning. So here, let's see, let me draw in the vertical right here. A little marker here. This is the vertical. This is where it should be standing, but because of the wind, it's leaning 6 degrees. So if it's leaning 6 degrees, we can actually find, let's say, this angle right here, okay? And again, it doesn't matter what we call that angle, we can call that angle B. Again, it doesn't really matter. How big is angle B? Well, if this is from the vertical, there's 90 degrees plus another 6. Angle B is 96 degrees. So we can calculate that. At a point 30 meters from the base of the tree, not the top of the tree, but from the base of the tree, 30 meters away, the angle of elevation to the top of the tree, okay, so if we go to the top of the tree, the angle of elevation, again, remember what an angle of elevation is, 22.5 degrees. Find the height of the tree. So they actually want this height right here. So I'm going to call that height H. Call that H. Again, that's the height of the tree if it were standing straight up. Okay. So if that's what I'm trying to find, that's what I'm going to start with, my unknown. My unknown, I always write that down first. What are you trying to find? So the height, H, is proportional to the sine of the angle directly across. So that's the sine of 22.5 degrees. Okay? And then what else do we know? Well, we know this angle here, but we don't know the side across from it. And we know this side here, but we don't know the angle across from it. So we need a pair. We need a side with an angle. Well, I have this angle. There's no way for me to find this side. But there is a way for me to find this angle up here. So again, I know two angles of a triangle. 180 degrees minus 22.5 degrees minus 96 degrees. That's going to give us the angle that is across from 30. And that is going to be 61.5 degrees. So now I can use this side with the angle across. So again, 30 is to the sine of the angle opposite of 30, 61.5 degrees. I'm trying to solve for H, so multiply both sides by the sine of 22.5 degrees. And practice typing it into your calculator. Obviously, your calculator should be in degree mode. And rounding to the nearest tenth, you get 13.1. And in this case, they were using meters, so it's going to be meters. Okay. So we'll do some more applications later on, but there's one example. Okay, so again, let's go back here and let's look at the given information. This was angle, side, angle. Angle, side, angle. And that was a congruence theorem from geometry. That does produce one unique triangle. There's only one possibility with that given information. Same thing with angle, angle, side, or side, angle, angle, however you want to say it. Okay? Okay, let's go back up here. I think I said side, angle, angle, you couldn't say, but you can. You can do side, angle, angle, or you can do angle, angle, side. Either one of those is correct. Now, if these are the if two angles are given, how many possibilities could this be? It could be only one. So anytime you're given two angles, you know for a fact that's going to be one unique triangle. Okay? Same thing here. These two angles are given. This third one can only be one possibility. As you're going to see now, that's not always the case based on the given information. So let's go ahead and let's look at the next couple examples. And we call this the ambiguous case. Anytime you are given side, side, angle, or angle, side, side, that is an ambiguous case. Ambiguous means not clear. So just based on the given information, it could be 0 triangles, it could be 1, or it could be 2. And I'm going to go through how you know based on the work that you will be doing. So the first thing I recommend, obviously, is to draw a picture, like I always do. And again, it doesn't have to be anything perfect. It's just some generic triangle. That's not a right triangle. Just keep that in mind. So let's draw some generic triangle here. Angle A, angle B, and angle C. Even if it looks equilateral, it really doesn't make a difference. Label the given information. Angle A is 60 degrees. Side A is directly across from it. Angle B, Side B is directly across from it. So there's the given information. So what's given to us here? Side, side, angle. Now what I want you to pay attention to is how big this side is compared to this one, if you go in this order. And I call this small side, big side, angle. Small side, big side, angle. This side's smaller than this one. Anytime you're given big side, small side, angle, that is when it will either be 0 triangles or 2. So let's find out what it's going to be. Okay? All right. So where do you want to start here? This is the given, so I know this. This is the other given, so this gets paired with this angle. So this is the only thing I can find next. So that's what I'm going to start with. Like I said before, I'm going to start with my unknown. But I can't just say angle B, it's the sine of angle B is to side B as what other angle do we know? 60. So the sine of 60 is to the side directly across from 60. So that's how I would set up that proportion. Again, always setting up my unknown at the top. Now I could flip these around, but then I'm going to have my unknown in my denominator, and then solving for an unknown in your denominator gets very confusing for some of you. So we're trying to keep it as simple as possible. Okay, so the next thing I'm going to do is multiply both sides by 14. Okay, and when I go to type this into my calculator, let's go ahead and practice. I want you to see what you will get. So personally, I would use your alpha y equals button to use your fraction bar. Make sure your calculator's in degree mode. And hopefully you practice that and you realize you get 3.03 for the sine of B. So sine of B equals 3 2 different times or 0 times? Well, we've already talked about this. The sine of B has to be between 1 and -1. So this is not possible. So the given information doesn't create a triangle. So there are no possible triangles with that given information. Well, why do you think that is? Well, if this is 14 and this is 60 degrees, 4 is not long enough to touch. I could keep moving it. I can move it over. I can move it over this way. It's never going to be long enough to create a third side that's going to touch side C. So no possible triangles for that one. Anytime you get an error here with this given information, the answer is 0. No triangles. Okay. Well, let's look at the option when there are going to be 2 triangles. I already told you there was going to be none. On here, there's going to be 2. So again, let's draw our picture here. Just colors here. Again, just drawing a generic triangle. I have angle A, which is going to be 58 degrees. Side A is 4.5. Angle B, side B, angle C. Okay, so you see this one is a little bit smaller. This one's closer in size, but it's still, given information is still small side, big side, angle. So that technically is the ambiguous case. Small side, big side, angle. Okay. Let's go ahead and set up the work for this one and see what happens. Again, this is the given this is given, so this is my unknown. This is the first one that I can find first. So the sine of angle B is to 5, as the sine of 58 degrees is to 4.5. So unknown to 5, sine of 58 to 4.5. And what do we do to both sides? We're trying to find angle B. We're going to multiply by 5. And we can go ahead and try typing that into our calculator. So again, try, type it into your calculator. Make sure you can do it correctly. Sine of 58 divided by 4.5. Again, using your fraction bar is probably the best. Multiply that by 5. And you end up getting the sine of B is 0.94227. Again, learn how to keep that in your calculator so we can be accurate. Now, how many possibilities is that? How many times is the sine of B positive 0.9? Well, again, we just learned in our last chapter that when sine is positive, there are two quadrants. First quadrant and second quadrant. So let's go ahead and take the arc sine of our answer. And again, use the decimal that's in your calculator so you can be accurate. I did angle B equals 70.437. So again, I'm just going to degrees. I'm going to keep this in my calculator and use it later because I don't want to round to the 10th and use, if I use this to the 10th in my work, then I'm only going to be accurate to this number right here. So you have to be careful. Use your calculator wisely. Okay, so angle B is 70 point, let's go to the 10th on here, 4 degrees. But you also know that it can be positive in the second quadrant as well, and that's the first quadrant. So how do we find the other angle that angle B can be? 180 minus 70.437 degrees. So in your calculator, 180 minus that answer. And the second possibility for angle B is 109.5 degrees. So with the given information, angle B could be 70 or angle B could be 109.5. And that's how you get two triangles. What happens is this 4.5 here, I could swing it in. If this is angle A, make that just a little bit bigger. If this is angle A and it's 58 degrees and this is 5, this side, this 4.5 is small enough that I can move it this way to create a triangle, or I can swing it over and connect over here as well. So I can take my 4.5 side and connect here, or again, I can swing it in and it actually will connect here at 4.5. So that's how you get the second triangle with that given information. And notice that this angle right here, which is angle B, will end up being obtuse. And that's what this is. This is obtuse. So small side, big side angle, one of two things is going to happen. You are going to have something that's not possible, or you will get something that is possible. When it's small side, big side angle, you have to remember that this possibility, your calculator gives you one. Again, you have to be smarter than your calculator, and you have to find the second one. which is the 109.5. So you actually have two triangles to solve here. Okay, and that's what we're going to do next. So I still have to finish this right here. So here I know that I know angle A and I know angle B, so I can find angle C very easily. So on the calculator, 180 minus, again, I'm going to use the 70.437 that's stored in my calculator, and I'm also going to subtract the 58 that's given, and I'm going to come up with the 51 points, rounded to the nearest tenth would be 6 degrees. So that's angle C on this triangle. Now I need to find side C. So again, I'm trying to find side C, so I'm going to start with my unknown. Side C is to the sine of 51 points. And again, it's if you use what's in your calculator, it's 0.562 degrees. Because you don't want to round and then round, because you have a rounded answer. So I'm going to squeeze this in here. Is equal to, again, you can use this ratio here, but what about if this is wrong? So I always like to stick with the given. This is given. So 4.5 is to the sine of 58 degrees. Okay, so how do you find side C? So go ahead and let's type this into our calculator. Again, use your fraction bar, 4.5 divided by the sine of 58 degrees. And then you're going to multiply that by, multiply both sides by the sine. And again, I'm going to go up in my calculator and I'm going to use the 51.56269 that is stored in my calculator, so I can make sure that I am accurate. And you end up getting 4.156. So if I ask you to round your final answers to a tenth, your final answer would be 4.2. Now that's for this triangle, the acute triangle. Okay, but as I said before, with this same information, the given information does not change. That's a very common mistake. The given information here can be used and it can create an obtuse triangle where the angle B is 109.5. So in this triangle here, angle C is going to be much smaller than it was in the original one. So if we go ahead and subtract, we take 180 minus 58 minus our 109.562696. Again, it's stored in your calculator, so you should just arrow up as we practiced in the last chapter, and that would be 12.4 degrees if you round it to the nearest tenth. Okay, so again, I'm trying to find side C. So C is to the sine of angle C. And from my calculator, it's 12.437 degrees. And again, using the given information, 4.5 is to the sine of 58 degrees. Now I already have this in my calculator, so I'm going to scroll up and I'm going to find it and enter. And all I end up having to do is to change, I can take out the angle that I have previously of 51, and I can use my 12.437 again that I have stored in my calculator to find side C. If you know how to use your calculator efficiently, then you don't have to type all of these numbers in. You just arrow up, and again, we've gone over that. You just arrow up and you select whatever it is that you want to reuse. For those of you who can't arrow up and select, we're going to have to update your calculators so you can do that. Okay, so rounding to the nearest tenth for side C is 1.1, so that's where you get your two solutions. Okay. All right, so so let's go ahead and take a look at the last one. Again, let's draw a generic triangle here. So we have angle A is 31 degrees, side A is 12, side B is 5. So if you look at the given information, we have side-side angle again, or angle side-side. However, what do you notice about this? This is big side, small side angle. Okay, big side, small side angle. Maybe you remember hypotenuse leg, or HL, from geometry. When this side right here was the leg of the right triangle. HL is a congruence theorem, hypotenuse leg, which means that you would only get one and only one triangle. And what would happen in that case is when you set this up, you get the sine of the angle would be equal to 1. And when you actually found the angle, you get 90 degrees. Well, on this one, as you can see, this side that's given here is larger. When the given side is larger than the altitude of the triangle. Okay, there is no way that this side is smaller than this altitude. Anytime this side is larger than the altitude, it's going to be big side, small side angle. And this right here will only produce one unique triangle. Okay, again, if you go back up here, this was the smaller side, larger side, small side, larger side. Those are the two cases that you have to worry about with 0 or 2 triangles. This one, big side, small side, one and only one triangle. Okay, so let's go ahead and see what we can find first. So looking at this given information, we compare these two together and these two together. So this is my unknown. So I'm going to start with the sine of my unknown angle is to 5, as the sine of 31 degrees is to 12. And again, you should know to multiply both sides by 5. And let's see what happens when we type that into our calculator. And again, feel free to pause the video at any time if I'm going too fast. When you multiply both sides by 5, you end up getting 0.214599. Well, that's possible. Okay, that's possible. And it's going to say, well, you're supposed to get 2 answers. Well, because up here, we got 2 answers. Well, you have to look at the given information. Small side, big side angle with a decimal between 1 and -1 is 2 answers. But in this case, I'm telling you, you need to pay attention ahead of time that this is only possible. There's only one possible answer for this. And let's say you go to find 2. I'll go over that in a second. But let's go ahead and find what angle B is. Take the arc sine of that decimal in your calculator, and you'll get 12.39 or 12.4 degrees. Okay, so what does angle C have to be here? Well, again, 180 minus, I'm going to use the stored 12.3920 minus the 31. Again, I have it in my calculator, so I can just use it. So I end up getting 136.6 degrees. Well, let's say you think there was 2 triangles. Okay, let's digress a little bit here. If this is 12, the other one is 180 minus 12, right? That's what we did in the previous example. So that means that angle B is 168. And if I add angle A to that, those 2 angles alone, the obtuse one of 168 plus the one that's given is more than 180 degrees. So even if you went and said, oh, well, this is the ambiguous case, I have to find the second option for this, when you go to find it, it's just way too big and not even possible to create a triangle. So I'm telling you ahead of time that if you see big side, small side, don't waste your time finding the second triangle because it doesn't exist. Okay? All right, so we have to find side C still. So last thing we have to find. Side C is to the sine of angle C. And again, I'm going to go back up in my calculator. It's 607 degrees. And again, I'm going to use the given 12 over the sine of 31 degrees. Okay. So now I will show you what we're typing in. I'm going to take the 12 divided by the sine of 31, and I'm going to multiply it by the sine. And again, I want to use the full decimal from my calculator. So if I arrow up, I select it so I don't have to retype it, and I know I won't type it wrong, and I know that I will be as accurate as I possibly can be. And there you get side C rounded to a tenth is 16.0. Okay, and that is the law of sines and the ambiguous case of the law of sine.